Hey there, good morning. Welcome to another video on math problem solving. Today's problem again is from Tiago Dorado. I really like this guy for creating such elegant problems. Try and solve this problem. You just have to find x. What's so awesome about this problem is that it's so elegant. Uh, it's so simple in just making a person understand what the problem is about. In this case, very easily you can figure out that you just need to find that length x, which starts off from the tangent of the inner circle and reaches the circumference of the outer circle. And it's a tangent to the inner circle, right? And for reference, you have two other tangents as well. 20 is the length from the inner circle to the one in the center, the circle in the center. The other one is a tangent to the circle in the center, going to the circumference of the outer circle, which is 21. So you have all of this, and how do you find out x? The clue is that you should remember the geometrical concept that a tangent is a point which is going to be at 90 degrees with the circle's radius at that very point. What I mean is when you connect the center, let's see if I can, yeah, if I can connect all the way to the center, you can think of this as 90 degrees. So that is your clue, or that is the fundamental concept that you need to understand before solving this. You can pause the video here and try and solve it yourself. And even if you're not able to, please go through the productive struggle, as you probably heard me tell umpteen number of times in all my videos that you absolutely need to go through the productive struggle in order to get the answer. Okay, welcome back. If the question was elegant, I think the answer is equally elegant. The reason is the only concept that you need to know here is Pythagoras theorem. And if you know this, you can solve this problem extremely easily. So let's draw the first triangle which contains x. So you have x and you have two other things which apparently happen to be the radius. So one of the sides of this triangle is R1, the other is R3. 3 because it's the third circle, right? And similarly, you can draw another such triangle with the side 20. Okay, so in this case, R1 is going to be one of the sides and R2 is going to be the other side. And let's draw the last one where R2 is going to be the side and R3 is going to be the hypotenuse. So there you have three right angle triangles where the hypotenuse or the side is R1, R2, and R3, and two values given 20 and 21. X is what you need to find out. So all you have to do to solve this problem is to basically write down the equation. So let's start with the equation which has x in it. So R3 squared, the hypotenuse squared, is R1 squared plus x squared. That's for the first triangle that I drew. The second triangle, R2 squared, is equal to R1 squared plus 20 squared, which is 400. And for the third triangle, it's again R3 squared, which is going to be equal to R2 squared plus 441, because 21 squared is 441. Okay, so what do you do with this? You have three equations, equation 1, equation 2, and equation 3. The elegance of the problem or the solution is in just identifying that you need to take equation 1 and subtract equation 2 and subtract equation 3. So if you do this, you realize that R3 square cancels out because R3 squared is equal to R3 squared. R2 square stays, that's minus R2 squared. R1 square cancels out R1 square because that's subtracting it out. But you also have a minus r2 squared, a plus x squared, a minus 400, a minus 441. So r2 squared also cancels out, and you can basically bring the constants to one side and the variable on the other side. X squared is going to be equal to 841, which is nothing but 29 squared. Therefore, x is 29. I hope you enjoyed this problem. I hope you find the elegance and beauty in both the question and the solution. If you'd like to see many more such videos, please do like, share, and subscribe this video without fail. Thank you so much. I'll see you in the next one.